Okay guys, today we're going to look at how we solve limits analytically with harder algebra. Might have to do foiling, we might have to factor, we're going to use conjugates, we're going to do all sorts of crazy things with limits. But let me show you a couple examples, and like I said, it's the same thing we did yesterday, but you got to do a lot of algebra before you can plug in a number. So the first one I'm going to look at is the limit as x approaches 0 of x squared minus 3x all over x. And I've said this many times, hopefully by now, but I'm going to say it one more time. I always try to plug in the number first. So if I plug in 0, the problem is I get 0 in the denominator. 0 over 0 is actually what I get. That doesn't work. And so what we need to do is do some algebra, or at least try to do some algebra. So I'm going to do some algebra. Hopefully you notice that everything in here has an x. So if I factor out an x in the numerator, I'd end up with x minus 3 times x all over x. And these x's cancel. So I end up with the limit as x approaches 0 of just x minus 3. So I plug in 0. So now I just plug in the 0, and you get negative 3, which is the answer. What happened with what we factored out right here? That means what this looks like is that starts as a parabola, but it's really not a parabola, it's just a line, and at 0, negative 3, we have an open circle. It's supposed to be a line. There you go. So there's a hole. Because you factored out something, that gave you a hole at that point. So the limit exists, but the function does not. So f of 0 for this original function was undefined. It's an empty set. But the limit itself is negative 3. Okay? So a lot of these that we're going to look at are ones where you graphically have a hole. Alright, let's try a couple more. That one, the algebra wasn't horrible. Let's try this one. The limit as x approaches 2 of 2 minus x all over x squared minus 4. Well, once again, if I plug 2 in there, I get 0 over 0. It doesn't work. So, we've got to do some algebra. Hopefully, when you see the denominator, your brain is already going, ooh, I need to factor. So I get x minus 2 times x plus 2. And in the numerator, I have 2 minus x. You don't need parentheses around it, but I did that for a reason. And hopefully you remember from algebra, I know it's been a while, but these two are almost the same. So if I multiply this by negative 1, right, I can factor out a negative is a better way of saying that. So I'm going to factor out a negative. So this becomes negative, which then I would make this a negative 2x, or negative 2 plus x if I factor out the negative. And down here I have x minus 2 and x plus 2. And you guys have done enough algebra that you realize that these two are the same thing, so they cancel. And I end up with negative 1 over x plus 2. And the limit, I still have the limit. I always forget to write it every step because there's too much algebra for me to write that every step. So now if I plug in 4, or plug in 2, it works perfect. I end up with negative 1/4. Okay, so there was an example with factoring. The next example I'm going to show you, no, I lost my numbers of what examples I was going to show you. Alright, this one is a little bit weird. I don't know if you've ever done this before. You've done something similar to it in Algebra 2. Alright, so this next example, sorry, I kind of had something crazy go on there. The next example is going to be the limit, and this one's a little bit harder than what you've probably done in the past, the algebra. The limit as x approaches 3 of the square root of x plus 1 minus 2 all over x minus 3. Now, if you plug in 3, you're going to get 2 minus 2, which is 0, over 0, which we don't want. That's a certain form that we don't want. So what we have to do here is a special algebra called using a conjugate. And you've done this in Algebra 2, but you haven't really used it like this. Anytime you have a square root and you want to get rid of a square root, you can use a conjugate. So I'm going to multiply by the conjugate, which would be the square root of x plus 1 and instead of minus 2, it's plus 2. But if I do that to the numerator, I have to do that to the denominator. So I'm going to multiply the denominator by that same thing. And I'm actually going to go through and make these all. Alright, once again, I got something crazy going on with the bell. Okay, so we're using the conjugate. I hope this comes out. We're using the conjugate, and like I said, we're going to multiply by that conjugate, and I kind of already have arrows in here because of my computer and the bell. But when I multiply, the denominator I'm not really going to do much with. The numerator is actually an easy FOIL, like I was saying, because if I multiply these two, they just become x plus 1 because the square roots go away. The inside and outside are going to cancel, and so I just get minus 4. The denominator, it's not much fun to FOIL it, so I'm just going to rewrite it for a second, and you're going to see something that happens. So, almost there. Let me rewrite this. Now, if I simplify the numerator, I get x minus 3, and in the denominator I have x minus 3 times the quantity of the square root of x plus 1 plus 2, which means these cancel. So we did a conjugate and we did some canceling. So remember, Mrs. Elgert never keeps writing her limit, so at the end I always put it back in there. The limit as x approaches 3 of basically 1 over the square root of x plus 1 plus 2. Well, if you plug 3 in here, that's going to give you 4. Square root of 4 is 2, so you end up with 1/4. Okay?